Hey, so this is my attempt to go the next step in terms of the workflows that we're dealing with for this class. A couple of general comments. First of all, I'm doing this, I'm not really thinking this through, or this is not a careful teaching moment. I'm just trying to give you some basics so that you can keep working on these workflows as we move forward. I will, as promised today in a thing on Teams, I'm going to create sort of assignments for everybody, and I am going to write assignments, meaning things to do for this project, but I am going to write, I'm going to try to write some basic drafts of assignments that you look at as you're doing this, so you have some idea of the context that we're talking about this in. Um, there's a lot of information here that really we're supposed to already know, so and I don't want to spend a ton of time going over things that you do know or that are basic. However, I'm sure that a lot of people don't have some of the basics, and I need your help to tell me what you think that is. So, if you get lost, I'm not giving enough information on, when I quickly go over some of the background, just, put that in your little set of comments, just remind yourself to talk to me about it at some point. Okay, anyway, so I'm going to dive into this. I guess the other thing to say is, remember, this is me trying to come up with a plan for the class. I'm not saying this is the order in which you would do these things on your own project. If you're working on precedents right now, for example, you could do this however you want to. It made sense to me to do the thermal analysis first, ties it into local law 97. It also, I mean, you could do either way, but it's controlled. We don't bring up the whole climate or the context, which is, complicated. So it's more pure, and that's what we're doing, is we're just learning skills. So I was trying to isolate the thermal aspects. So we've done that. And now we're going to talk about daylighting. So this is the building that the model we were playing with before. I have, it's the same, we're in the same file. So I have my thermal model here with, everything that we used to model before. It's basically, though, the idea is this is just a rectangle, 125 foot square. I did create these 5 zones for my own reasons that, I think that it's maybe not the way we keep it, but that's the way we modeled this. And we went, just to remind us what the deal is, we went through a whole series of simulations, starting with sort of a 1960s imagined building, moving up to something that's as energy efficient as I sort of could imagine it. And we adjusted the the idea was to head toward carbon neutrality. The thing I want to point out now, though, is the reason I'm bringing this up, is that the main way we talked about the sun in the thermal analysis, obviously, is as a heat source. You should be used to these graphs by now. If not, we should talk about it. This is a energy balance graph showing heat gains and losses for a variety of different components of a building. The orange here are windows. We did do things without windows, and so when we started having windows, we were looking at, can we, these amazing models can separate out summer and winter, or just on a monthly basis, the heat gains and losses from different components. So, for example, the orange here, we were saying that, like in this model, there's a lot of heat gain in the windows, through the windows in the summer, but not so much in the winter. So that would be an indication that maybe there's some things we can do to try to flip that around. And that was the way we were interacting with the sun on the thermal side. We should remember that the sun, and this is such an amazing thing to me that, that's so elegant about even just this technical side of architecture. The sun is light that we see, and light that in daylighting, we're going to talk about light in 2 basic ways, maybe more, but what I'm thinking of right now is 2. One is the amount of light coming in. So, and we want daylight coming in because, one thing, it makes the building more energy efficient because we don't have to use electric light when it's on. Also, though, you need to have a view, you need to have light coming through, and so those 2 are connected. but also humans like sunlight is part of our psychology and our biology. So we want to encourage a healthy interior environment with sunlight. But so that's one side, enough light, but not too much, and too much can cause tension and pain. Glare is an example of something that's painful. So both of those things, like the glare and the comfort of visible light, is only represented in this pretty small portion of the electromagnetic spectrum, way down here at the bottom. This is the visible light, and the light the part that the wavelengths we were talking about in the thermal analysis are way up here, much longer. And so the way that we can design as architects elegantly with this resource is, so in other words, we can say we want heat but not light, or we want light but not heat, and we can really create a nuanced design with the sun, because these are so separate in terms of their, even though they're coming in through the same channel, this swath of light, they are separate in their wavelengths, and so we can separate them out in our design. So we're talking now about this portion of the solar spectrum. So let's turn off. Well, let's turn on the thermal model, the daylighting model that I made. And now I'm going to turn off. We can see it's same. It's a portion of the same model. I decided only to do one floor because if we look at this, there would definitely be some difference, especially if we had a site. The first floor is going to be different from the second floor because there's going to be reflection. There's also, if there's context, that's going to make a difference. So I'm not saying this is the same, but the concepts are very similar for these three floors, and so it just seems like a good way of learning it to start with a single floor. So what are and let's talk a little bit about what this sort of very basic design is. Again, I was not trying to design a real intelligent space. I just wanted to make something that was symmetrical so that we could understand how we could compare the different facings of the building. So what I came up with was just I used the same 125 square foot footprint, and then I created these zones basically that are, let's call them rooms, separated somewhat by partitions, and then also in the interior there's glazed meeting rooms essentially. So it's kind of it's an open office with maybe these are offices, conference rooms, whatever, meeting rooms in here, and then a central core space. So what else to say about this? There is a ceiling and a floor. You don't see them when I have their layers on because I have gone in and made them transparent. And I did that because when we're running these simulations, you'll see they don't actually, they're very fast, but they also pretty much immediately start showing you results. So you can be watching them while you're doing other things and waiting for it to finish, or deciding if you need to let it keep going because you've learned what you need to learn. So if we have the point is, if the ceiling is off, it's on, it's going to be have a material applied to it and therefore be part of the simulation, but I won't see it. So remember that the visual, the graphic window is not the same as the simulation window, and or the simulation, what's on in the simulation, and so you have to keep track of that. Okay, what are the different ways we can simulate daylight? The most obvious one we've done before, all of us, and that's just this simple visual. Let me put on my cap here. I just did a little cap for this reason. And the point of this is that this is the way you guys have probably done this in the past. It's very powerful and wonderful. This was not around when I was starting, so this is still pretty cool. And we should use it because the first thing we should use is our knowledge of the sun and daylighting as we learn about it. So that we have, as we're designing, we have an intuition as to how the forms we're creating, how they will perform. But then we use these tools on the fly to help sort of hone in on things. But we know that we're in New York, so in the winter in New York, the sun's going to be, here's the solar window. It's going to be lower in the sky in the south, and in the summer it's going to be higher in the south, and it's going to rise very far to the southeast in the summer and far to this. To the northeast in the summer and far to the southeast in the winter, etc. And so we can, even at this point when we've modeled this space, we can start looking at things like, okay, wow, I bet you I'm going to need some, or I got to think about maybe if this is an office, that's going to be a lot of light in there, I can tell. Can I already start playing around with some kind of shading devices and seeing what effect they have? Like, let me turn this one off. I can just click this on and off now and, see that I'm at this time of year, whatever it is, I've cut, that direct light in half. This is in February at around noon. So I'm saying that tool is always here, and you should go back and forth between it and the more detailed modeling. Let's just turn it off for now, though. So how else can we model daylight with this interface? Oops. Cap. So let's just do one of these as a way of introduction. I'm going to do a point-in-time illuminance model. What this is we're going to pick the portion of the building that we want to have the sun coming into, and we're going to pick a time of year, an hour of a year, and determine and model the light coming into it. So what would we need to do that? Obviously, we need the climate data. What's this sky thing? These are models of the sky. Like, so for example, the Perez, which usually I see people using the CIE clear or overcast. Perez uses data from the climate model in its model of the background, the sky dome. So I don't think we need to get into any more detail on it than that. Just realizing that these are different models. I think I used CIE Clear for everything I did in the runs I've done, so I'll just leave it at that. So all we need to do to run a model like this is pick our background, which would take some research if we wanted to see the difference between them, but we can also just use a default. We need to, anything that's going to be part of the daylight simulation needs to have a material assigned to it. So if you have something that's on, like this wall, for example, that does not have a material, it will not be a part of, the sun will not hit it in the model. So you have to be careful of that. So let's go and look at that drop down. Basically any layer that's on will show up in, oops, let's see, like if I turn off the ceiling, it leaves the material palette. So whatever layers are on will show up in the dialog where we can add materials. And if we don't add materials, they will not show up in the simulation. So right now I've got a preset. We've got acoustic tile for ceiling, some carpet for the floor, just some paint for most of the interior, just a clear glass on the interior glazing. This right now is a specific kind of glass. We'll talk about that in a second. So let's just let me click on one of these. So if I want to change this, I just click and open up this material library. I can search it by name. Like I can put concrete in here, or start typing concrete, and it's a search engine. We have the basic. Actually, won't even it's not so important. The opaque materials, which is what other is. Basically we're talking about how much light is reflecting off of or going through the material. So you'll see with this concrete, 100 Memorial Drive, which I think I said Frank Lloyd Wright. Or is that East Vanderbilt? I don't remember. Anyway, you see it has a T-Vis, which is visible light transmittance of 0%. That makes sense. It's reflecting light in different ways. We won't talk about that. Then if I go to, all I'm saying is I would just have to change, I could pick whatever I want and select it, and it would populate it would apply that material to that layer. Let's now let's just go look at glazing and talk about that because that's the most important part of this. So if let me just delete that. You should know this already, but well, I shouldn't say it that way. I'm just letting you know I don't want to spend a lot of time on it if it's not necessary, but please talk to me about this if you don't understand it because it's very important. Um, we have, if you get a new window, there'll be a label on it, a National Fenestration Registration Council label, and it'll have TViz, which is the visible light transmittance. It's a percentage. You will have solar heat gain coefficient, which is the percentage of heat that's going through the glass. So again, they were talking about heat and light. You'll see if you look through this list, there's a lot. We can get things that are very different. So like I have here, and so point 0.17 means 17% of the solar heat's coming through the glass. So let's see, let's go down to something that's, here's something where, here's a glass assembly that has 51% visible light transmittance, but only 22% solar heat gain coefficient, or solar heat passing through it. And we can find some that will flip that, where there's a lot more like, okay, here's, well, I won't go through it. Just the point is that we have glass packages now that are very engineered and complex. Well, they're easy to understand, but I mean, I'm sure they're hard to make. That allow us to tune these variables. So let's go over them quickly. TViz is the visible light, so that's going to be, like we were saying, the amount of light that's coming through that will be part of our calculation to whether or not we have enough light in the space to make people comfortable. Then RViz and front and back is the percentage that's being reflected by the glass, and because of different coatings, you can tweak these and change them. The U value is a thermal characteristic, as is the solar heat gain coefficient. So those are things that we talked about in the thermal simulation. But we're going to need to think of these all together at some point. Okay, and so that's one thing that we're going to have a lot of. That's one of our major tweakable variables is the type of glass. Okay, so we have to set all those variables or all the materials, and then we need to say what we won't worry about luminaires right now. That's adding lights. We can also add skylights, that tubular skylights, which are a really cool technology that allows you to have small openings that are not going to overheat the building, but that let indirect light into the space. And so for example, we could bring some sunlight into this core here with a tubular skylight. I'm not going to talk about those right now. So we need to identify what areas we want to be looking at in this simulation. So I'm going to click on areas. I have already named and set the areas in here. So let me just draw, if I wanted to create a new area, I would create a surface, and then if I say I want to add a surface to my model, I select it and hit enter, and then I can name it. I can decide the sensor spacing. This is actually something that's like for example, in LEED, there's a specific sensor spacing that you're supposed to, or there's a minimum that you're allowed to do. You have a target workplace offset that's a LEED requirement if you're doing LEED. So these are all important variables. We're not going to worry about them right this second. So we'll just leave the presets. And then we get this work plane. This is where we're actually, the little black dots are the sensors. This is where the simulation is going to occur. And that's where we are measuring daylight in any kind of either certification requirement or just as part of intelligent daylighting design, because it's where we're going to be working. And if it's and it could, if this is a warehouse, maybe this we wouldn't have any offset because we want to be able to see the floor, whatever. That's a decision we make. By the way, I don't know if you've experienced this before. Sometimes these are turned over, and if that's true, this is the direction right now of this surface, and so I can flip it. And if I do that, these turn down. Let me see what happens if I say okay to that. Yeah, that's interesting. Oh, maybe I just did this. I didn't do the. Maybe you have to do it before. Let me try that. So I'm going to take my surface. Let me close this. I think I don't have the surface anymore. Let me flip it. Okay. All right. I'm going to flip it. All right. Now I'm going to add. Let's see if that's still flipped. Yeah. Now I'm going to add my surface or my work plane. Yeah, and you see what happened is that it went underneath. So if you ever see a black, or your presets may be different, but just realize that you have to flip surfaces sometimes, and it's not always predictable what the presets are or how Rhino is going to interpret what you want to do. So just realize that's something you want to be aware of. Okay, so let's just pick these two corners, or this corner and this. Let me turn this off. I'm going to pick the southeast corner and the south little bay here, and run the simulation on that. Now, the only thing we have to do is just pick a day, which it was already, let's say, okay, we're going to do February 20th at 12. Um, so if it's 12 o'clock, the sun's, should be out here in the front, so there should be plenty of light in this room and plenty over here, and there's not going to be as much coming in from the side. Let's see if that's true. And so you see now this is running already. We have 4 passes and it's going to do 100. So and the way this technology works is it's already estimated. So we're pretty close already without even going through the process. So if you want to be really accurate, you can wait to the end. But if you don't want to, you're getting a lot of information that you need right now. And this is what I thought. So we have a lot of sun here in the south because we're in February at 12 o'clock or so. So let's just stop it and reset this to, let's do the same day, but we'll do it at 9 in the morning. And so now we're going to assume there's going to be a lot more sun over here and less here. Let's see if that's true. And you see I can go back and forth in my comparisons. Um, it's not as much as I thought it would be, so I'm going to mess around with a little bit more. Um, but that's what's cool about this. You can go, wait, why is that? That's I thought we definitely have more to the south, so that's true. That I'm assuming the sun means it's going to be more to the south. And if I open the solar window, I'll know why. Um, the solar window being this. Oh, it's running, so I can't go to that. Let's stop that. Let's go to, let's go to sometime in January. Oops. Yeah, we'll go to about the solstice, and go even a little bit earlier. Now that really should be very different. Let's see what happens. Sorry, I paused because I didn't like the day I picked. So this is better. I went to a little bit. I went to March early in the morning, so we'll definitely be getting more sun from the east, and then that's what we see. Um, and then we can quickly compare, right? So this was, the February day at different hours of that day, and this was the March day. So we can do a quick point of time analysis if we want to. This gives you an idea of the basic setup. So we have sky, materials, and areas. And the cool thing about Climate Studio is that a lot of what we do, we use the same inputs. So if I then, and for me, point of time, it's going to be more of a specific analysis that I'm going to want if I have a problem I'm seeing in my design, or a question I've got, or I've got, I don't know, like this is the boss's office, and we know that she's there at a certain time, and we want the light to be perfect or whatever, you know. Um, uh, so to me, what's more useful are these other, well, I shouldn't say more useful. I'm just saying that the focus of what I did in this initial workflow study is the daylight availability. And so what we're doing here is calculating well, let me put, we're calculating the amount of daylight in the building for the year, but we can do it queued to different standards or just a daylight factor. Daylight factor, you may remember, is the exterior ambient, like background light, divided by the interior, and this is like in lumens, the interior measured light, and you get a percentage, and there's certain sort of rules of thumb as to what are good percentages. So this is not like a certification standard, but for example, LEED 4.1 is, and so I think in the class we'll just use LEED 4.1 option one as our benchmark, because I'm saying that for all of our workflows, I want to have an actual benchmark that we're shooting for. So for the thermal analysis, it's going to be the local law 97. So for daylighting, let's do LEED 4.1 option one. What is that? Well, let's see. This is it. It's pretty simple. Well, there's more to it, but in terms of what we're talking about right now, we have two variables: spatial daylight autonomy and annual sunlight exposure. Spatial daylight autonomy is simply a measure that's been made up to say what is a comfortable amount of light, or a minimum amount of light, not comfort, I'm sorry, to for a space to be autonomous from a daylight standpoint. In other words, essentially a subjective measurement of how much is a good amount of sunlight to have as a minimum. And so that's three. So you see SDA 300/50%. That means 300 lumens, at least 50% of the occupied hours. So that's one thing that we're going to measure. And then the second is annual sunlight exposure. And you see that here as ASE 1,250. That's ASE 1,000 lux for 250 hours. So any place that has more than, that has 1,000 hours of, 1,000 lumens for 250 hours a year will be outside of this metric. And so we have these amounts that we are shooting for these percentages for spatial daylight autonomy that we get points for in LEED. So 40, 55, and 75 are 1, 2, and 3 points. And then if we have an annual sunlight exposure in any space of more than 10%, then we have to explain it. So that's going to take more discussion, obviously, in the class, but that's what I'm going to say about it now. Let's go, and I think that really these models are a good way of learning these standards. So let's talk about it. So if I am doing a daylight availability study, the cool thing about it is that really, first of all, I'm going to go turn off this. I just remember, if I come back to my results and I click on the deselect all, I won't have any of the results on the graphic screen. And let's do this. And if I don't want to see what I was just modeling, I can come to my areas and turn those off. So for this first daylight study, what do we need? We're going. All we really need. We don't need to do anything else. We have to have the materials set, like we already have, and glazing chosen. I'll actually just show you. I'll start running one, but then we'll just go through them. Remember, we would have to say, okay, I want. So I've got my climate, I've got my materials chosen, and these are the layers I want on. Let's make sure everything's here. I've got my glazings on, my mullions are on, all my interior surfaces. I don't want any shading right now, so I'm going to turn those off. So this is my baseline. And if I then, I'm not going to have blinds on right now, and no areas are visible. So if I come and I select all my areas, I'm ready to go. That's all I need to do is to run this. And if I'm going to hit go, and you'll see it's a little slower to get going, but it's still pretty fast. And once we see any kind of results, like I say, we're like a 90% accuracy or somewhere around there. I found that letting it go is a good idea because it does adjust. But it's an incredible tool that I can't tell you how much better this is than it used to be, than these things used to be, because you really can use it to iterate. Like you can say, oh, whoa, that's way more than I wanted, so I'm going to stop this and go on to something else. Or, this is interesting. I'm going to let this keep going. And while it's going, you can do whatever you want. I can model things. I can look at other variables, etc. So it's pretty nice interface. Um, okay, but let's just stop that one. And we see we already have some results, but I'm going to delete it. To delete I'm selecting it here, and I'm coming to X, delete it. I have to say yes twice because that's permanent. So let's go through some of the studies that I did and talk about because that's really everything has been done that we need right now. We can just run a series of simulations to test what we've got going on. I'm going to turn these off for now so we don't have that visual there. I guess I'll leave this on. Okay, so the first thing I ran was the base case, which was just this glazing like you're seeing it here, with clear glass. And so what is clear glass? By the way, when you do this, if I come here to this is the results. I've already run these. I hit this information button, and everything about the model is here for me, or most things. This is awesome. I wish they did that for the thermal analysis. They do. There's this report you can print out, but it's pretty. It's a CSV file. It's not very clear. So I don't have to make some kind of detailed record of what I'm choosing here because it's pretty much telling me what I need to know when I click on the results. So what I did is I used I think it was a single pane glass. It's got an 89% visibility. Oops, no, that's wrong. I'm looking at the ceiling. Where's the... Right, here's the exterior glass, and it's 91% visible. Let's go actually look at that. That's probably a single pane piece of glass. I'm just gonna come to my materials. I don't even need to, I'll just select something. I'm not gonna, if I go to glass assembly, I think in the thermal there was a default, there was a single pane. I don't know if there's any, let's see, layers. Yeah, there's clear single pane. That's probably what I used. 87%. I think that's right. So it's just a single piece of glass. That's what Ed Hall has, but it's not legal anymore to do that. I don't think in most jurisdictions. All right, so let's see what we got from this. This run. I've got so here's how this breakdown works. This is my lead credits for. Remember we're doing lead 4.1, option 1, that I showed you briefly what that meant. I'm getting 3 points, which is the most I can get, but there's an asterisk. And why is that? What's going on here? Well, let's look at this. First of all, my SDA, which is saying if I'm getting enough light everywhere, wow, it looks great. I'm getting completely 100% glazing, the light that I need to do the best I can to reduce electric lighting usage. And, if this were the only metric, people would be comfortable and happy. Problem is I have a lot of spaces that are, they're saturated. They have too much sunlight. So our ASE is of 1,250 is running pretty rampant. And you can see we have a ton of light here. This is just the average lux. And you can just mouse over these sensors and see. I mean, yeah, this is like 15,000 lux is a lot of lux. For a workspace. So this is not going to work. But this is, like I said, this is at Hall. This is, I mean, this is a typical glazing package for an older building. They're pretty problematic, which is why they often have blinds. And so the second thing I did, second analysis I ran was just adding blinds. And let me show you how you do that. So blinds none visible. If I come and select my exterior glazing here, just select that layer, select the objects, and then I click on blinds. I can add blinds to all of them. I'm not going to do, well, I guess I will. And then I can just turn them off. And then if I edit them, you see that there's just some presets here. There's basically an operable blind or dynamic glass. Let's not even worry about dynamic glass right now. And just keep the presets, basically saying how much visible light's being allowed through and how permeable it is. The idea with these is that they're now going to be, whether or not they're mechanized or not, they're open unless 2% of the sensors in the building and in the space that these blinds are in front of are receiving direct sunlight that is of a high glare amount. Let's just put it that way. Okay, so they're gonna, even if you were closing them manually, the simulation is gonna close them automatically when there's direct sunlight, too much direct sunlight, which isn't very much hitting the space. So I'm actually going to select all these and deselect them. But if I now go to this second run with the blinds, I can see by adding blinds that made a huge difference. So it's stained glass, added blinds. But what else happened? So I'm down here, 100%, 40.3, just really high lux. I add the blinds. I see that my blinds are closed a lot of the time. Almost over 30% of the time, blinds are, as an average, blinds are closed when people are occupying the building. That's pretty bad. And that's typical, though, if you look around the city, because people aren't designing with daylighting well or for daylighting very well. So we're going to need to fix that. And we've dropped down our SDA to 87%. 75% gets us 3 points. If we're just playing the point game, we're still well within our abilities here to get all the points. And we have way too much. We have a lot of areas where we're overlit, which is why we have the blinds open so much. I mean, closed so much. Let's actually look at that. So we see, and this little icon is showing us when the percentage that the blinds are open. So on the south side, our blinds are only open 39% of the time. So that's terrible, right? 30% of the time on the east and west, or 68% on the west. And then they're on the north side, they're always open because there's no direct sun coming in on the north side, right? So that's makes sense. So we don't really need blinds over there unless they're for privacy. Okay, so what are we going to do? We're going in the right direction, but the blinds are open. They're closed too often. We still have way too much overheating, or I'm sorry, we're oversaturated with light. Let's look at the outputs down here. We can see that the SDA for each space, which is good, but then there's a lot of places where we're at like 50, 40, 80% of the time that we're saturated with light. Now, if you go in the blinds column, where these are all zero because the blinds are fixing that, but they're fixing that by closing. When you have a blind over glass, why is the glass there, right? I mean, if that's happening too often, you should have an opaque wall there because opaque wall has better properties for so many other things. One of them being thermal. Covered glass is just sort of it's just bad design. If it's, I mean, that's said too stringently, but that's the basic idea, right? Okay, so what do we do next? And by the way, you may notice as I'm talking about this, I'm just moving this, you got to get good at seeing the part of the screen you want to see because there's not enough real estate here for all the stuff you need. Okay, so the next thing I did was, and by the way, you see these little icons, they're all, so this one, the lead symbols for the daylighting, that was going to be for a glare study we're going to look at in a minute. So the icons change. This this icon here is for our thermal analysis, so it's pretty well organized. The next thing I did was I just replaced the single pane glass with some low T-Vis glass. So let's look at what that is. Let's see. Yeah, down here I'm at 36% visible light coming through. So that's way different than whatever the 87% was before. And what did that do? So we dropped our SDA quite a bit. We're now below, see, we're at 2 credits now. But our ASE has dropped somewhat, but not a huge amount. But our blinds are open a lot more often, so that's heading in the right direction. And we have way less sunlight coming in. So those are all, it's going in the right direction. By the way, I don't know if I mentioned it, the little asterisk next to the points is, you can see it here, saying that there are spaces, occupied spaces that have 10% ASE above the threshold that we talked about, the 1,000 lux at 250 hours or more. And so to get the credit, you have to explain why that is true. And it could be, for example, you say, well, we don't, those are rooms that people don't occupy, so it doesn't matter. Or you could say, well, we're using blinds. That's probably not the best idea because, first of all, those blinds could be engineered out of the actual, value engineered out. And thirdly, there's just better ways of doing it architecturally. So we want to be conscious of that, and we want to try to get our ASE below this threshold in all of our occupied spaces. Okay, so we've got some double pane, more modern glass in there now. It's heading in the right direction. Let's do a different. Let's look at the same exact setup from a different vantage point. And remember, in this daylight availability, we have all these other. I don't know if I think I should. Yeah, I did show you these. There's German. There's European standards we could use. It's really the same study and the same simulation, just using different metrics. So just realize those are there. So let's do a annual glare study. And the way these work, we're using the same. I'm going to come over here and deselect this. I have to say what areas I want, and I'm going to use all my areas. And everything else, as long as I don't want to change anything, if I just want to do the exact same study, then I can just go. So again, the amazing thing about this, one of the amazing things about this interface is it's so easy to set up different simulations. Okay, so here we are. I'm waiting for it to start. It's going to show you what happens when it does start giving us data, and then I'll stop it and show you the results for this particular layout. And again, this may be faster or slower on your computer. It depends. There's a lot going on, so it can take a little while. Okay, now it's starting. And we're getting this little graphic in all the spaces. What this is, it's basically, this is a person, or this is an eyeball, and this is a view direction and view angle. And so what all this red is saying is that everywhere where it's red, more than 5% of the time, we have unacceptable or intolerable glare. And there's been studies done, and this is not part of standards, that if you have more than 5%, people will start complaining and not want to be there. So we want to get as much, well, if this were a pool, maybe it wouldn't matter. Or if it were a greenhouse and we knew it was designed for the certain kind of plants that we wanted in there, needed this kind of sunlight, it would be good. But if this is an occupied space, we want to get as much of these red pie slices out as we can. You can see that this is slowly getting better, and it will get a little bit better over time. I'm only at 12 passes, and there's going to be 100. But I'm going to stop it and go to the, I'm also going to delete it just so I don't get confused later. Well, that's probably not true, but just to show you that you want to try to keep things clean. Just keep your desk clean here. So if I come back and where were we? We were at this first base glare study, we have a lot of glare, right? And we already knew that from this study. And if we compare these two, we can see that the red pies are, focused wherever the yellow area is, where it's overly sunny. So, that makes sense. Uh, what can we do about this, and how else can we look at it? One thing that's interesting is that we can come into any of these viewports and do get a rendered view of this and see what the actual source of the problem is. So if I'm going to pick this view here, or I'll do this one. And so then, and if I see as I'm scrolling over all these viewport these pies, how this graph over here is changing because these are the outputs for that specific place. So I want to see this, or I can even let's do this one at a time. Oops, didn't select it. I'm going to look at it in. Let's see, February. I'll just leave that. That looks pretty good. And by the way, so this is again another one of these things where it's kind of small, but oh, it doesn't even expand. It's kind of a drag this a little bit. So we see that we have the months of the year, so I can pick where. Obviously, the red is well, it's these colors here, and any place where it's gray, it's imperceptible glare. 10% is perceptible. I mean the yellow is perceptible, orange is disturbing, and 37 is really bad. So that's what this is showing us. So if we were to get around 12 o'clock at this, it looks like here, it should be pretty bad. And I'm going to, so I'm, picking, here's 0, so midnight, here's 12 noon, midnight again. I'm going to pick what looks like to be a intense glare moment and hit this camera. That opens up this camera dialog. Oops, wrong thing. And it's now rendering this. I'm going to switch to false color, and we can see, and this sometimes the default might be like 2000, so you're just going to get this, really not as helpful graphics. So you need to play around with these things. So I'm changing this to a number of lumens that will uh, be sensitive enough to show us the sun. By the way, this is we can move around. This is a fisheye lens view. And one point to make here, so if I'm, even at this time of day, if I'm looking this way, it may not be a problem, or if I'm looking back this way. So if I had a computer screen pointed this way, it might not be a bad thing. So there's a lot to this, right? But there it is. There's the sun. We can see why it's glary right now. And I could start thinking about, well, what do I want to do about this? Do I want to try to block the sun? At this time of year, with some kind of physical thing? Do I want to change the glazing? Do I just want to lay out the room so this isn't a problem? Lots to think about, but this is an incredibly useful tool. Okay, what we know right now is that we got too much glare. So what I decided to do next, as I'm quickly moving through this, just as an example, was to add some shading. So I added shading 1. So I just added this basic shading. I think there's more to, yeah, this. And you'll remember that this is a basic shading pattern that we used in the thermal model, so this will be something we can compare to that. Of course, part of this workflow is that we'll need to circle back around and check once we get a daylight analysis that we like, or daylight concept that we like, then we have to look at the thermal analysis portion again and see if we'd screwed it up by whatever we've done here. And that's obviously something that we need to be thinking about as we get better at this all throughout, kind of just as just this constant feedback loop of fun. All right, so what did this do for us? A great thing about this, right, is that we can compare. So our last daylight study was this. It had a lot of glare, so that's what showed us there. So So then by adding the shading, we get to this. Wow, that's a big difference, right? That's really helpful. So and why did we do that? Well, we knew intuitively that if we didn't have this shading, We're going to get a lot of sun on the east and west. It's going to be overheating us. We were saying to get rid of this portion of the not overheating, I'm sorry, over daylighting, some kind of shading on the east and west would be good. To get rid of some of this here, maybe we'll just start with a horizontal shade. Anyway, this is just quickly doing something to give examples. And so then the result of this shading intervention is this change. And make sure I'm still going here. So let's see what we've accomplished. Well, before we were at 2 credits with the asterisks. That's because we're not at 75%. I think it's 40, 55, and 75, I think, for the 1, 2, and 3 points. So with this, we went up to 3 points because we're at 80%, which is very good. If we look at that, we see that we've got a nice amount of, or most of the area is covered in, is bathed in usable light. We might argue that we could turn off these central areas and say that they weren't, but they're occupied. So I think in lead we'd have to. Let's not even get into the ins and outs of it. It's just we chose to have all the occupable spaces on. And we're at 10.9%, so we're really close. Well, by the way, that 10.9% is an average. We need to get all of these down below 10% if we want to get rid of that asterisk. Now, like I said, if we were really doing this on a project, we could do that. We could deal with the asterisk by making a written argument as to why we have more than 10% in some of the occupied spaces. But we're having, for this, let's just try to see if we can get rid of it completely. And we also have our blinds are open much more often. We're now up to 88%. And if we look here, we're at 74. I think we were at 30-something%. 44 at that point. I think we had one that was lower than that. So we're heading in the right direction, definitely. Let's see what we should do next. Let's try. So we want to get this down further and maybe have the blinds open even more. So how are we gonna? Well, we need to focus on the south side, right? Because this is where our over daylighting or our over illumination is occurring, and that's where most of our blinds are closed probably. If we go to blinds, yeah, we've still got, they're closed, 25, 20%, 25, 17%, things like that. So let's work on that. So the thing I decided to do was add some, and I was not very, these are big, these were maybe too big. I'm not designing this here. I'm just trying to create examples. So I added this southern shading. And the result there was a really good improvement. We went from, let's see, we didn't lose much of the SDA, so we're at 78%, whereas we were at 80 before, but we went from 10.9% of the over illuminated to 5.3 as an average, so we're doing really well there. We still have a couple of places where there's more than 10%, it looks like, so let's see. Yeah, we still have, the souths are still, could use some work if we want to get rid of that asterisk, but I think at this point, in the written narrative that we gave to lead, we could say, we're really, we're using blinds here, not very often, and it really is at the very front end of the south usable space. So if we didn't have any computers right here, for example, and we started our computers back here, maybe these are plants, or these are little places to sit, and look out at the lake or whatever's there. There'd be a narrative would be appropriate at that point. Okay, so then. But I decided to look at this from a glare standpoint. and maybe tweak this further. So I'm on the same shading with glare. We have still a lot of glare over here on the east and west side, and too much, I think. Well, there's some work we could do on the south. Again, if we're just playing around here too. So what can we do? If we go back and look at our sun shadows, and let me put the cap on this guy. Um, so it's afternoon, and we're in, you know, sometime in the winter. Um, so it's, a little after 3, and a lot of sun coming in there, right? Um, Actually, let me go turn these off. And I'm going to turn these off. All right, so that's our floor in there. Um, and we go back to the sun. So one thing we could do if we look at the angle of the sun here, right? It's coming in from the south, right? It's never going to get as it goes down this time of year, it's going to come down right about here. It'll be normal to those windows, but right now it's angled. So what if we tried to add um, something like that? What's that going to do? So let me get rid of this guy. So like for example, just at this time of day, if we toggle back and forth, actually if I just turn this one on and off, let's see, where is it? This one. We see that this doesn't change anything. So, but if we take this one off, right, toggling this on and off. So this is the shading we've got now. If I add this, and when I say it doesn't change anything, this is the same shade. It's just rotated 15 degrees. That we do cut the sun down somewhat here. Now, this is the cool thing with this model. We would spend a lot of time, or we could spend as much time as we wanted to tweaking it. But let's just pick 15 degrees and see if we get, if we get any kind of discernible change. And so I modeled that. Let's see what else. Um, so basically, okay. Sorry, I'm getting a call. So uh, here's the result of that adjustment. So this was before, or the shade adjustment. This is after. We can see that what we thought would happen is happening. That we're getting that a lot of these these painful glare areas are going away. It's a lot of work could still be done there, but the point is that we can see the effect, and we went from 13% to 10.5% of painful glare in the whole building. So that means that there's a lot more that was reduced on these sides where we were focusing. Um, then, and we could keep going with that. For example, so we could play with turning those around, or rotating them more. Just keep iterating. Let's just mess with the south a little bit. Um, if we again, this is where you might go in and say, okay, um, let me look at the glare right here, and let's see when is that, and we'll look at it the same day we were looking before. Should be. Let's see what happens. So the point is not, I'm saying, okay, what can I do about all of this red on the south side? Um, what's the, so we're seeing that, as to be expected in February at noon, the sun is coming in directly from the south, the solar orb is high in the window. So it's possible then if we added something like let's see, I can't like this. I thought I had two of these, but I guess I deleted one, so I don't remember which is the right one that I actually used. Um, that we might be able to reduce some of that. So let's look at that again with this on. Wait, let me make sure that that's got a material to it. You gotta always remember to check this kind of thing because um, so this is the light, yeah, concrete, yeah, okay. Because if I had this on, that light shelf on and I didn't have a material connected to it, it would not be in the model even though it was on. It looked like it was. Uh, Secondly, this is just a surface, right? So I mean, it's not going to be that great because it's 1 point thick. But I think we might have some effect. So let's just see. We go back to like that model we were just looking at, and yeah. So that is, you can see there. That's the light shelf I put in, and that's definitely blocking the sun quite a bit. So much so that we've gone from intolerable to perceptible just by adding this, little light shelf right here. And of course, we could tweak it more, mess with it. But the result here was that we went down quite a bit. Um, I can't remember. This is weird. I wonder how. Oh, yeah, this is a little bit confusing here. Yeah, these are the two different ones. I did one at 8 feet and one at 7 feet. Shows you there's a little bit of difference. 7.7%, 8.1%, but not too much. My point being, you can fine tune this. Um, and so now, if we run this exact, check it all again with our daylight availability, run it with these same settings. You see that we have pretty incredible results. Actually, we have so little over illumination that we can barely see it. It's just these few little spots. So that was actually very successful. The adjustment of this. Let's look at that. Before we adjusted that, we had this. That's for the second shading. For the third shading, it would be this. And we've totally gotten rid of anything on the south. I imagine there's some blinds open down there though still. No, not very much. So that really did a lot. Now, whether or not that's going to be practical for other things, that's why we're here. We would check it against the thermal, and we have to think about views. That's another thing we're going to do. But where are we now? So we've got our full 3 credits. We're at 80% of the desired illuminance levels to where we're going to have much lower electric power density, lighting power density. We're going to save money on lights. People are comfortable in this space. We have a nice even distribution of light, and blinds are almost never open. We might not even need them. We could run this without the blinds and see what we got. All right, so that to me is a lot of stuff, but the baseline for our daylight availability, our daylight simulations for the class.